7, 6, 5, 4, 3, 2, 1. Let's go! Yes, sir! Let's doing it.
Hi, my name is David. Welcome to my Maker portfolio.
That there was the incredible feeling of accomplishment you get after months of hard work, when everything finally comes together and works how it should. The first step to building a great FRC robot is identifying wants and needs. Once I did that, my first prototype was born. Starting off with the drivetrain, one of the main improvements I wanted to make was on belly pan design. We removed unnecessary material through pocketing while keeping structural integrity intact, creating a lighter, more efficient foundation where electronics and wiring were easily mountable. The shooter was initially designed with the chain and sprocket mechanism, but space limitations and motor placement issues forced me to redesign. I transitioned to custom gears for better weight distribution and reliability. Initially, I tried using polycarbonate gears for their lightweight properties, but they bent under load due to slight tolerance slips here and there. I switched to pocketed aluminum gears, which maintained strength while minimizing weight. To further improve durability, I widened the gears to handle force distribution better. After testing, I found that the custom spline geometry aligned perfectly with the COTS 10DP gears, delivering smooth and consistent performance. Moving on to the intake, I immediately began designing 3D printed intake funnels to help center the game piece upon intake. I quickly realized there was too much friction between intake rollers at the bottom, and a design flaw within the indexer where the center distance between the two indexer wheels was too small, which made it hard for the ring to travel into the shooter arm. But with competition day so close, I needed to find another way to fix the problem without redesigning the shooter completely. After a lot of iteration on the intake plates, changing points of contact on the rings, I decided to completely remove the silicone tubing over the bottom rollers, so the front roller would grip and bring in the game piece, and the bottom roller would simply kick it up and into the indexer. Now finally, all we had to do was code the robot. October 19th, the day before the competition, me and the lead programmer spent the entire day learning all the API with all of our new motors, which required a completely new software ecosystem. My initial plan for indexing was to log motor current values to figure out whether a note was rubbing on any wheels. However, with one day left, I found photoelectric sensors in our back room, CAD'd and cut them out for them, and used them to make our indexing logic a lot smoother and more intuitive. After that, we figured out pose estimation and collected data for a lookup table so that our robot could create accurate shots every time into the goal. After a couple thousand lines of code, the robot shot its first self-calculated shot.
We're locked in, guys.